Good afternoon. Today we are going to deal with 3 by 3 matrices and 4 by 4 matrices. How to solve them using the simplest way possible that I'm going to bring to you. So maybe just keep watching. In case you haven't subscribed, just subscribe and even like my videos so that they can be recommended for many people to still watch. So we can start with 3 by 3 matrices, how they are done, how to find the determinant. So let's say determinant of 3 by 3 matrices. It is very simple actually. For example, you are given a matrix with these elements. Assume you are given a matrix with those elements. How to find the determinant of the given matrix? It is very simple. So what you normally do, just come and draw here another one. It will be 1 2 1. We have 2 0 4. We have 4 3 2. Then this is the matrix. And since we are finding the determinant, just draw the first two columns again here. So you have 1 2 1. Then we have 2 0 4. Then this is the other matrix that you have formed from using these two first columns. Then Uh, remember, earlier you had learned about the leading diagonals, leading diagonals, and we have a secondary diagonal, secondary diagonal, a diagonal. So we have secondary diagonals. So what you normally have to do, then you start with the leading diagonals. You draw like this. It is all that one. We also have that one, and finally we will have this one. Then you add all of them. So 2 times 0 times 2, we are getting it is just 0. You add it to 4 times 2 times 0, 4 times 2 times 4, we are getting 16 times 2, which is just that 2. And finally we are having 2 times 3 times 1, which is just 6. So we are getting our matrix. This diagonal is giving us that 8. Then you come again now to the secondary diagonal. You start with this. So we are having 1 times 4 times 0, which is just 0, plus we are having 4 times 3 times 1. This one, which is just 12. And we are having 2 times 2 times 2, which is just giving us 8. So on adding this, you are getting it is 20, and here we are having that 8. So you take a determinant, you just take the leading diagonals minus the secondary diagonal, secondary diagonals. So it will be that 8 minus 20, and you are getting it is 18. This will be your determinant for the 3 by 3 matrix that you have. So kindly, in case you are not seeing it clearly, I'll just say that you introduce another columns, these and these, here, just next to the given diagonal. just next to the given matrix. Then after introducing it, you start with leading diagonals, the one which is full, then you add it to the next one, then you add it to, and remember it is the product. Then after that, you take the secondary diagonals, you start the one which is complete, plus this one, which is ending with the introduced matrix, then this one. And after adding, you take some that you had from leading diagonal, which was 38, you subtract it from the one that you had from secondary diagonals, and you are getting it is 20. Let me now introduce 4 by 4 matrix. Let me just first clean the board. Let's look at determinant of 4 by 4 matrix or matrices. 4 by 4 matrix can be given in this form. Let me use small numbers because of the multiplications. Just very small numbers. Let me just use very small numbers. Small numbers. So this is the matrix. We are having our matrix as 4 by 4. Remember, it is having 4 columns and 4 rows. So once again, those are the rows, then we have columns. So what you normally do is you first come and pick this one, the first one, then you will ignore the entire row and the entire column. So it will be 1, then you will have a 3 by 3 now matrix, a 3 by 3 matrix after removing the whole row and column. Then you subtract. The signs will just alternate. After addition, you go to subtraction. So it will be -2 into. After picking 2, you ignore the entire row and the column. So you will remain with. So this one you will ignore. It will be 3, 1, 2. Then this one will have 1, 2, 3. Then you have 2, 3, 4. You had it is just 1 into you ignore the row and the column. On ignoring the row and column, you will remain with 3, 1, 2. You have 3, 1, 2. Then you have a 1, 4, 1. We have 1, 4, 1. And finally, we have 2, 3, 4. Then finally, you subtract, it will be 0. After ignoring the row and the column, you will remain with 3, 1, 1, 1, 4, 2, and 2, 1, 3. So we are having 3, 1, 1, 1, 4, 2, and finally 2, 1, 3. But since you are multiplying with 0, everything will just change to 0. Then we have this one. The determinant of 3 by 3 matrix, as I had shown you earlier. Let's just start with this one. It should be a 1, 1, 2, 4, 2, 3, 1, 3, 4. Then you introduce another row of the first 2 columns, the first 2. So we will have 1, 4, 1, and a 1, 2, 3, just like that. The leading diagonal is giving us what? It is 1 times 2 times 4, which is just 8, plus we will have 1 times 3 times 1, which just be 3, Then finally we have this one going like this, going like this. So 2 times 4, or we are having it is 8 times 3, which is 24. Then we have the secondary diagonal. We have 1 times 2 times 2, which is just 4, plus we have 3 times 3 times 1, which is just 9, plus we have 4 times 4 times 1, which is 16. So you take the leading diagonal, which is 35. This one is 35. You subtract it from 16 plus 9, 25, 29. So that 5 minus 29, which is giving you 6. Then you multiply by 1, you are getting it still 6, plus the second part, which was this one. Let's do it the same way. It will be 3, 1, 2, 3, 1, 2, 1, 2, 3, then 2, 3, 4. After that, you will multiply with 2, which is you will subtract. So let's introduce another column here, which will be 3, 1, 2, 1, 2, 3. Then you take leading diagonal like that, which is 3 times 2, 6 times 4, which is 24, plus we have 1 times 3 times 2, which is 6, plus we have 2 times 3 times 1, which is also 6. Then all this, we have now the secondary diagonal, which is 2 times 2 times 2, which is 8, plus we have 3 times 3 times 3, which is 27, and finally we have 4 times 1 times 1, which is just 4. So we are having 26 plus 6 plus 6, which is 36. This one is giving us 36. Then we have 27 plus 4, which is that 1, plus this, which is that 9. So 36 minus 39, which is giving us negative 3. Then you are multiplying with the negative 2. This is negative 2 now, which is now giving us 6. So you'll come and add 6 to the other 6 from the first matrix. Then finally, we take this one, 3, 1, 2. It is 3, 1, 2, 1, 4, 3, 1, 4, 3. Then we have 2, 1, 4, 2, 1, 4. Then let's introduce another column of the first two columns. We have 3, 1, 2. Then we have 1, 4, 1, like that. Leading diagonal will be 3, 1, 3, 4, 4. So 16 times 3, which is giving us 48. Plus we have 1 times 3 times 2, which is 6. Plus finally we have this, which is giving us 2. So this will be 56 on the leading diagonal. Let's check on the other diagonal. We'll have 4 times 2 times 2, which is just 16. Plus we have 1 times 3 times 3, which is giving us 9. Plus we have 4 times 1 times 1, which is giving us still 4. So 16 plus 4, it is 20, 29. You take 29, you subtract it from 56. So 56 minus 29, which is giving us 27. Which is giving us 27. So determinant will be the 6 plus 6 plus 27. It is 6 plus 6 plus 27, which is giving us, this is 39. and that is how we calculate the 4 by 4 matrix. The 4 by 4 matrix. What is important you have to know is that if you have picked one, you ignore the whole row and the column. Then you pick all those other elements which are remaining. And if you have picked two, you ignore the row and the column that is having the two. If you pick one here, you ignore the row and the column, and you pick the elements which are remaining here. If you pick 0, you ignore the row and the column, then the other elements which will form 3 by 3 matrix. Then you find determinant of 3 by 3 matrix, then you multiply with the element that you picked from here, and that one will lead you uh, into finding the determinant for 4 by 4 matrices. So that is the end of the lesson of today. So just in case you haven't subscribed, ensure you subscribe, you share, and the most important thing is to like my videos so that they can be recommended by the YouTube, so that many people are able to watch and also subscribe. So welcome.